Alright, what's up everyone? In this video we're going to be going over doing reflections of figures over some different equations of lines and also about finding the line of reflection. So remember that a reflection is a mirror image, and in order to create this mirror image we always need a line of reflection or a line of symmetry. And also just remember these fancy words that the Regents loves to use, these words rigid motion here. What this means is that it's a transformation that the size and shape of the object do not change. So since when you create that mirror image, right, we're preserving all distances. None of the distances of side length should be changing. None of the angles should be changing, which further justifies that a reflection is a rigid motion. So these are some lines of reflections that we have worked with so far already in this unit. So we've dealt with the x-axis, which is here, and you guys should be highlighting that on your papers as well. We've dealt with the y-axis, which is here, and you guys should highlight that as well. And then we've dealt with different vertical and horizontal lines. So this form, a reflection over the line of x equals k. K can be any number. So in this example, k equals 2 right here. And what this is saying is, no matter what point I pick on this line, if I look at the x-coordinate, it's always going to be 2. Now the same idea holds for when you're doing a reflection over the line y equals some number. Now in this case, we have the line y equals 3. And again, the concept here is if this is your line of reflection, no matter what point you pick on it, it should have a y-coordinate of 3, okay? Now, two new lines of reflection that we're going to work with are the lines y equals x and the lines y equal negative x. So the Regents loves to use these two. These are kind of like foundational lines that you kind of should know what they look like. But if you forget, whenever you have an equation in y equals, what you can do is just go into your calculator. So in your calculator, if you click the y equals button, you can type in y equals x, and then you can look at the table of values by hitting second graph, and then you can just plot a few of these points on your grid, and then just draw a segment through them. So just to go over this, right, the first point I see is 0, 0, so you plot that, and you only need one other point. So you can plot, I'll usually like to plot one a little bit further away, like 5, 5. Boom, and then all you need to do is draw and you know what, maybe I'll even plot 3 just to be safe. -3, -3, and then you just draw a line straight through that. And the same holds for y equals negative x as well. If you go y equals, and instead you write negative x, you will be able to look at the table of values, and you can plot some of those to help you get an idea, because you always need to sketch the line of reflection. So even if it's something a little bit different, you can always plug it into your calculator and graph the table of values that way, or use the table of values to help you graph. So segment AB has the coordinates of A, 5, 2, and B, 8, 6, and we want to construct the image of AB after a reflection over the line y equals x. So the line y equals x is a foundational line that you guys should remember what it looks like, but again, if you forget, you can go to your calculator, but that's the line y equals x. Now the only difference in creating this mirror image is that we are going to be counting in 2 directions. Now let me show you what I mean by that. So if we want to create the mirror image of A, we would need to count the distance diagonally. And if you guys remember from our other units, like, we can't ever count the boxes diagonally. That's not going to give us an accurate number. So what we can actually do is we can count in 2 directions. So we're actually going to count from A, and we're going to go to the left until we hit our line of reflection, and that's going to be 3 units. And then what we're going to do is count 3 boxes up. So A prime is going to end up in this spot right here. And again, we got that just by counting 3 units to the left, or we counted until we hit our line of reflection, and then we went up. So A prime is the point 2, 5. Now we need to do the same thing for B. So we're going to count in one direction until we hit our line of reflection. So we go to the left, and we see that that is 2 units, and now we need to count 2 units up. And if we do that, we're going to get that B prime is equal to 6, 8. Now if we connect A prime and B prime, that is going to be the image of AB after we reflected it over the line y equals x. So again, the only difference here is that you're counting in 2 directions. Since your line is slanted, you can't count just in one direction. You can't count diagonally. So to make sure we're precise, we count to the left and then we count up. So this is actually a reflection rule. This is pretty interesting because whenever we reflect points or figures over the line y equals x, what you'll notice is the coordinates are just flipped around. So originally we have 5, 2, and that became 2, 5, right? We just kind of swapped these places. And the same thing for 8, 6, right? When we reflected that point over the line y equals x, those coordinates just flipped around. So this is a reflection rule. And again, you can remember these if you want to, but if you don't remember, you can always use the grid to help you out. So now we're going to go and reflect a figure over a slanted line. So it says triangle BCD has the coordinates B, C, and D, and we want to reflect that over the line y equals -x plus 1. Now this is a case where, again, you need to sketch your line of reflection, but if you don't know what it looks like, just put it into your calculator. So let's go to our calculator, and in y equals, we're going to put in -x plus 1, and then we're going to take a look at that table of values and plot some points. So we have 1, 0 is the first point I see, and then I'm going to go to another one. We have 7, -6. And then we have, I'll go in the other direction just to give a randomized point. We have -3, 4. And now what we can do is, with a straight edge, as precisely as possible, we draw through. If I had a straight edge, now if it's not accurate, your reflection's going to be wrong, right? So your line should look something like that. And I plotted it more precisely on this next slide here. But now what you'll notice is that the line of reflection is kind of in the middle. It cuts through your figure, right? But if that's the case, you do the same exact thing. You just work point by point. So first, let's reflect point B. So for point B, again, we count left first, and then in this case, we're going to have to count down. So we're going to count left, 1, 2, 3, 4, 5, 6, 7. And then we're going to count down 7 units in this case. So we have 1, 2, 3, 4, 5, 6, 7. So B prime is going to end up over here. And the coordinates of that point are 0, -6. Now, we need to do the same thing for, let's choose a different color. Let's do the same thing for point C. Now for point C, it's a little bit different because now we need to count right to our line of reflection, and then we're going to count up. So that's only actually 1 and 1. So point C prime is going to end up right there, and that is going to be 7, -5. So C prime is 7, -5. Okay. Now, lastly, let's do point D. Now, point D, again, we're going to have to count to the right to get to our line of reflection. So 1, 2, 3, 4. And then we're going to have to count up 4. 1, 2, 3, 4. So D prime is here. And the coordinates of D prime are going to be 6, -1. So again, the figure looked a little crazy. But all we need to do is just count in 2 directions no matter what. Now what you'll notice is when your line of reflection is cutting through your figure, you're going to have a really weird looking image, but as long as you go point by point and reflect the same exact way that you would if your line of reflection was outside of your figure, then you're going to be good. But in this case, your pre-image and your image are just going to overlap a little bit. So now, let's talk about properties of lines of reflection. So a reflection, again, is a mirror image. Now, to create that mirror image, we replicate the distance of points on both sides of the line. So in this case, just to conceptualize this, I know that if I calculate my distance from A to my line of reflection, and I calculate my distance from A prime to my line of reflection, I know that those distances should be exactly the same, right? Same thing for B and B prime, right? If I calculate my distance from B to my line of reflection, and then B prime to my line of reflection, I know that those distances, again, should be exactly the same. If those distances were not the same, then we would not be able to create that mirror image. And then the same thing holds for C and C prime, right? If I calculate those distances, I know that the distance from C to my line of reflection, and then my distance from C prime to my line of reflection, we know that those should be the same as well. Again, otherwise that mirror image would not be able to be created. Now, we're going to be working with creating these equations of lines or equations of these lines of reflection. So we need a couple of things. We need two things to create our equations of a line. So we need the slope and we need a point on that line. So for this, you got to figure out the segment that you're going to be using. So you can connect any point on your pre-image and image. So in this case, we're going to be using A and A prime. Now, the next thing we need, because remember, for the equation of a line, we need a point on that line first. So the point on the line of reflection, right, in this case, it's going to be this one right here. But that point must be the midpoint of whatever segment you decide to create. So remember, to create the midpoint, we have to do x1 plus x2 over 2. And then for the y coordinate of our midpoint, we do y1 plus y2 over 2, right? So here, our coordinates of A are 1, -4. And our coordinates of A prime are going to be -5, 2. And we can go ahead and label x1, y1, x2, y2. So for our x coordinate of our midpoint, we're going to get 1 minus 5 over 2. And that's going to give us -2. And then our y coordinate is going to be y1 plus y2, so -4 plus 2 over 2. And that's going to give us -1. So the midpoint, or we can guarantee that this point is going to be on the line, -2 comma -1 is this point right here, right? We're guaranteeing that that mirror image is created if that is the midpoint, right? So now we need the slope of the line of reflection. So this is an important fact that you guys have to know, is that the slope of the line of reflection is always going to be perpendicular to whatever segment that you chose in the first step here. Okay, now also, going back to the midpoint one, it says the midpoint of the segment, it says the line of reflection must go through the midpoint, otherwise a mirror image is not created, okay? Now, we need to know the slope of our segment first, right? If we want the perpendicular slope, we need to first know the slope of this segment that we've created in the first step. So again, to find slope, we know that that's y2 minus y1 over x2 minus x1. And the good thing is we already have our points labeled. So we have y2 is 2 minus -4 over -5 minus 1. So we get 6 over -6, which means that our slope, our original slope, is going to be -1 over 1. But what we want is the perpendicular slope. So again, that's the negative reciprocal. So that sign is going to change. So we're going to go from a negative to a positive. And then that fraction is just going to be 1 over 1 again, right? Which is just 1. So now we have what we need. We have our slope and we have a point on the line, and now we just plug it into this equation. So again, though, our x1 and our y1, those have to come from the midpoint, okay? So we have y minus -1 equals our slope, which is 1, times x minus our x1, which is going to be -2, and then you can go ahead and simplify. So we get y plus 1 equals 1 times x plus 2, and this is a perfectly acceptable equation of your line. However, you can also manipulate it, and if you manipulated it, what you would have to do is distribute this 1 out, so it would become y plus 1 equals x plus 2, and then you subtract 1 and subtract 1, and you get y equals x plus 1. And that is also, so these are equivalent forms right here. So what I boxed here and what I boxed here are equivalent equations of our line of reflection, okay? So remember, just to wrap it up, we can follow these 4 steps every single time when we're trying to find the equation of our line of reflection. And just remember, when your line of reflection is slanted, you need to count in 2 directions. So you're either going to the left and up, or to the left and down, or to the right and up, or to the right and down.